Okay, I've got an application of the parametric equations here, and I've only got one because they're all basically the same. We throw something, we hit something, fire a bullet, a rocket, whatever. Um, so you can see there's two generic forms of the equation, and I double checked the lab manual and WebAssign, and everything is in feet. There might be other examples. I didn't check all the other notes that I didn't create, and you might find something on the internet in general that's in meters. So the difference is this coefficient of the square term, that minus 16, is specifically for feet. If it were meters, it would be different. Now, there are a couple of questions where you have to create the equation, and you can use this generic template as you see here. V is velocity, and then theta is the angle given, and then the h is the initial height above ground that you're given. But for the most part, we give you the equation in the future. And the x equation is always the distance, the horizontal distance, and the y equation would be the vertical distance or the height above the ground, like that. So for our specific baseball example with the numbers there, you can see the specific equations in my solution here. And then we have some additional questions to ask. And there are always variations on these questions. So like the part A, it might be, how far from the batter is the ball after a second. That would involve the x equation. This is the height above ground, so it's the y equation, like that. So we just plug the 1 into the y equation, type it in the calculator, there's the answer. Straightforward. For some of the other questions, there are some algebraic formulas that you need to know. So one for the vertex, that's the part B answer. So the H and K are the symbols we used in algebra class, to the H representing the input value, in this case time, at that maximum vertex, and the K value represents the output. In this case, it would be the height above ground. So you solve for the H first, and you can see the A, B, C letters are the same A, B, C from your algebra class. So that how long does it take until the ball reaches its maximum height? Negative b divided by 2a. You can see a little on the right there, and then type it in the calculator. And then take that number and we plug it into the y equation to get that maximum feet. Be careful about rounding too much or rounding in the middle of the calculations, like that. So if I had rounded this to 1.5, then my final answer might have been off a little bit. If I had rounded the sine of 20 degrees to something, my final answer might have been off a bit. So be careful about that. Okay, so part C and D are a little bit more complicated. So let's go to the next page. And part C, you could really solve this in different ways. So you might experiment with that. But we're given both an X and a Y. The 10 feet tall would be the Y value, and the 385 feet would be the X value. So we could really solve for either equation to get the T, the time it takes to then get there. So I chose to use the X equation. We're given the 385 feet, so I plug that in for X. That would be the time that it would take to get 385 feet away. And again, you can see I'm cautioning you against rounding too much. This line is what I typed in the calculator. I didn't take 385 divided by all of this and then round it and then plug it into the y equation like that. So you do have to be careful about rounding. And until you experiment with all the various ways of rounding, you don't know whether one is off too much. But I'll have students, they'll go cosine 20 degrees and they'll round it to whatever that is. I'm in degrees there, 0.94. And then they'll multiply it by the 145 and then round it, and then 385 divided by that and round it and square it and round it, and you get the idea. So my caution is don't round anything until your last step And if you do round, like I did in the example for part B, go out several extra decimal places. So maybe the final answer says round to 2, and then you go to 4 on one intermediate step, like that, etc. So just to, and you see my words here, just to phrase what the math is. So the X solves for the time it takes the ball to reach the fence, and then the height at that point is from the Y equation. And the question we were asking is, will the ball clear a 10-foot fence 385 feet away? And because at the 385 foot mark, the ball is 15 feet in the air, yes, it will clear that fence. And then the last question, part D, is if nobody catches the ball, then how far away will it then hit the ground? And that's going to be the quadratic formula. So that's going to be the Y equation. So basically the question is, when it hits the ground, the height is 0. So the Y equation set equal to 0, and then the quadratic formula, you can see written all that out there. That figures out the time it takes, and then we plug that number into the X equation to figure out the distance away. And again, be careful about the rounding. So there is a lot of calculation going on here, so you really need to practice with the calculator, because there's no trig. The only trig is I'm using the cosine or sine button on the calculator. So practice what's on WebAssign. There's a couple of questions. Practice what's in the lab manual. There's a couple more questions just to get that idea. And that's all of that video.